All right, I wanted to introduce section 3.4. We're doing some binomial distribution stuff. And so here is the information from our text. With binomial distributions, we've got a number of trials. N denotes the number of trials. And then we have successes or failures. P is usually used to denote the probability of success, and Q, the probability of failure. And success and failure aren't necessarily good or bad like they typically are, but they're just the outcomes. Something can succeed, and that could be it works or it doesn't work. So the sum of P and Q, they go to 1. So you might see that we have P hat, Q hat eventually, and those kinds of things. So if you know one, you know the other because one is the complement of the other. So with binomial distributions, you have success or failure. That's why there's those two outcomes. Similar to what we had before, we've got some terminology things here. The interesting thing, the mean is NP, which N is the number of trials, P the probability of success, and the standard deviation is the square root of NPQ. These are things you're going to need to commit to memory so that you can do those. Now, I have a neat little video that kind of goes through an exploration with this. If you don't want to understand all that, that's okay. We're going to use the binomial distribution function in Excel to give us a lot of answers. Excuse me. When we do that, true will be a cumulative distribution up to a point, and false will give us the exact value of that outcome. And that'll make a little bit more sense when we get into some questions. So I'll jump now to questions, maybe. Just want to bring up something here. We've got a WAMAP question, and I'm going to use Excel to do the work. So here's that. Anyway, so seed is planted. It has a 75% chance of growing into a healthy plant. So in this case, I would say the probability of success, a healthy plant, 75% as a decimal. If 7 seeds are planted, what's the probability that exactly 1 doesn't grow? So N is 7. We have 7 trials. And we want to know the probability that exactly 1 doesn't grow. Now, this could be the first one, the second one, the third one, the fourth one, fifth one, sixth one, seventh one, but it's just exactly 1 doesn't grow. So when we go to do our binomial distribution here, notice it says S, the number of trials, or no, excuse me, the number of successes. We want exactly 1 to not grow. So that's going to be 1. Trials, that's N, 7. The probability of success. Now here we have a 75% chance that it does grow. So the probability of success would be 1 minus that. So I have options here. I could do 1 minus 0.75 right here. This is success. In this case, we're wanting it to not grow, which redefines success. And then here, if we do true, it'll be everything up to 1. If we do false, it's exactly 1. So we want false here. And then we let it kick out our probability. Now, we could have figured out Q here equal to 1 minus P, and then done a similar thing. The probability of 1 not growing would be equal to, again, we have a binomial distribution. We have the successes, 1, trial, 7. The probability that it doesn't grow, redefining success here. And then again, if we have just one outcome that we're looking for, we do false. This gets us the same thing. So kind of 2 ways to look at the same question. These probabilities go in as decimals, rounded to 4 decimal places on our general rule. A poll is given showing that 60% are in favor of a new building budget. If 4 people are chosen at random, what is the probability that exactly 1 of them favor the new building project? So similar question. Okay. Question 2, no, 3 here. About 2% of the population has a genetic mutation. So I'm saying that's a success. and 2% as a decimal is 0.02. Don't put it as 0.2, that'd be 20%. 100 people are randomly selected, so that's our sample size. Find the mean. So we're looking for the mean, mu. It is NP. And so we just need to multiply this, and there's our answer, 2. Now you might have been able to do that in your head. That's all right. Having a little work there. Similar question, about 7% of the population has a particular genetic mutation. 800 people are randomly selected. Find the standard deviation of the number of people with a genetic mutation in such groups of 800. So another question here, question 4. Probability of success, 7%. Sample size of 800. Now we're looking for the standard deviation, and so we need Q for that. So I'll do 1 minus P to find Q. And then our standard deviation, sigma, is the square root of NPQ. And I do not remember how accurate we should be here. Doesn't say 7.22. Okay. Anyway, so there's kind of the introductory thing and a couple of questions. I'll probably post a couple more videos of me working through some questions. Let me know if you have any. Thanks for watching. Good luck.